Alright, this video lesson is going to show you what to do when we have all the types of compounds mixed together. So far we've been looking at them individually, ionic compounds by themselves, molecules by themselves, and acids by themselves. But what do we do when we mix all the compounds together? How do we incorporate that into our naming and writing? So essentially, this is what you're going to do. It all comes down to whether the compound you're dealing with is ionic or molecular. Acids are going to be treated separately. So if I want the name for the acid, I'm going to be very specific and I will say name the following acid, meaning that I want the acid name for the material. Okay, so it's going to be very clear about the acids. You're going to see at the very end of this one, I'll show you an example where it looks like an acid, and I'll tell you what I'm going to accept for something like that. Alright, so number one, we've got BaClO2 with a 2 out here. First thing I'm going to do is I'm going to identify this as either ionic or molecular. Since I have barium in here, that's going to be ionic, right? Because it's a metal and a polyatomic ion. Right away I'm going to use my rules for ionic compounds. Okay, so barium, and if I look at the periodic table, barium is an alkaline earth metal, not a transition metal, so there's no stock number. Whenever I'm writing names, I'm looking for stock numbers, so no stock number here. And I just named this, and this would be chlorite. Okay, so I know this polyatomic ion as chlorite, so that would be barium chlorite. Okay, next one we have is CrO3. Again, I'm looking for whether this is ionic or molecular, right? Acids are separately. You're going to treat those separately. So chromium and oxygen. Chromium is a metal. Oxygen is a nonmetal. Therefore, this is ionic. So I have an ionic compound. I have an ionic compound. So I'm going to use my rules for ionic. Chromium. All right, and if I look at where chromium is on the periodic table, because I'm looking for stock numbers, it's a transition metal, so it requires a stock number. To figure that out, I'm going to use the oxygens, so I'm going to write 3 oxygens here because of the 3 down here at the bottom. Each one is a -2, -2, -2, total -6. And on the Cr side, or the chromium, I have 2 of them. They overall have to be +6 to balance out the -6. So therefore each one of those has to be a 3+ and a 3+, so therefore my stock number is a 3 based on the charge of that chromium. Okay? Alright, so again the rules here that I'm following are whether it's an acid, or sorry, whether it's ionic or molecular, and if it is, I follow the rules that I have for each one. So step 1, ionic or molecular, and then I follow the rules. So I just finish with oxide. Okay? So again, I come to the next one. I ask myself, ionic or molecular? We've got nitrogen and oxygen. So since I have nitrogen in here, or I'm sorry, no metals in here, I have 2 nonmetals, I can go ahead and use my rules for molecules. And the rules for molecules are to use prefixes for the number of atoms. So that would be dinitrogen, and I would say monoxide. Not monoxide, but monoxide. Alright. Remember in the first one, if I had a mono, I would drop it. I wouldn't use mono on the first one, I only use it on the second one. So dinitrogen monoxide. Okay, so first thing I do is identify what we have. Down here, metal, nonmetal, ionic. So I follow the rules and balance charges. So I have zinc, and I think about, do I need a stock number? Well, it's a transition metal, but it's one of those special ones that does not need it. And then I just named the other one, which is chloride. So there we go, zinc chloride, no stock number. Alright, the last one, if I follow my rules, it's 2 nonmetals, so I'm not going to use my ionic rules for naming. Okay, I could think of this as a molecule, 2 nonmetals. So what I would do is I'd say hydrogen, and I would call this, hydrogen monobromide. So the technical name here would be hydrogen monobromide if I were to treat that as a molecule. Now, I don't necessarily say don't use the acid names here, so I guess if you thought of that as an acid, I could see how you could think that this is either a molecule or an acid. That kind of makes sense. So if you wanted to call that let me write that properly. Hydrobromic acid, that would be acceptable too. So if I were to ask this on a quiz, I would accept either one of these names would be acceptable because of the fact that you have could identify that as an acid. So just be careful with that, okay? It's not a big issue, but I would take either one of those answers would be acceptable. All right, so if I go the opposite direction and I try to write the formulas from the names, I'm going to do the exact same thing, right? The first thing to do is identify whether this is ionic or molecular. If it's an acid, it's going to be pretty obvious because it'll say hydrobromic acid. It'll say it right in there. So first thing to do is identify whether it's ionic or molecular. Metal, polyatomic ion, that's going to be ionic. So I write the symbol for copper, I write the charge for copper, which is +1. I write nitrite, which is NO2 minus. I balance my charges, so the overall formula is going to be CuNO2. That would be my final answer, CuNO2. Alright, this is pretty simple. Again, I'm looking at whether it's ionic or molecular. Prefixes kind of give it away, so there's going to be molecular. Second thing you want to check is make sure that you have two nonmetals, and there I have phosphorus and oxygen, two nonmetals. So I say phosphorus, 2 because of the diphosphorus, oxide, tri, so I put a 3 there. There we go, diphosphorus trioxide. Number 3, calcium is a metal, so that's ionic. So I'm going to go ahead and put the ionic naming in here. So I'm going to say calcium, that's Ca2+ based on its position on the table. Dichromate is Cr2O7, 2 minus. And pretty simple to balance here, so I just put Ca Cr2O7. And there's my calcium dichromate. And the last one, looking for whether it's a metal and a nonmetal, and the nitrogen and the fluorine are two nonmetals. So it's going to be a molecular substance, and I just translate it over. Nitrogen. Notice there's no mono in here, so just one nitrogen, and trifluoride. And there you go. That's how you would deal with ionic compounds and molecules mixed together, and how you would also treat the acids. All right, thanks a lot.